Good morning from Cybersecurity Insights. I'm Gary Spiteri. I'm part of Cisco's Advanced Threats team. I'm a security engineer. And this morning, I've been down on the stand. Just wait for this to finish. I've been down on the sands talking about how you deal with data breaches. It's a really topical discussion. There's a lot of problems that are happening around data breaches. There's a lot of nervousness. There's current legislation now in play around having to disclose data breach. But the thing is that the customers that I talk to, one of the problems is they actually don't even know that they've been breached, or they're just waiting for that terrible moment when they're having to read in the paper that they've had a breach. So what's been happening has been really about the fact, and the kind of things that I talk to my customers about. They can say that they've got lots of different technologies. You know, they might have things like, a firewall, an IPS, web gateway, email, etc. All of these different types of technologies that essentially are all stacked together into what's called defense in depth. Everyone's got this. You've got this. Literally everyone has. And there are so many people that then say, and I'm protected. Look at all of the layers that I have. Now, the problem is, and the kind of fun that I then say, is that when they talk about this, I actually ask them, do they know what they don't know? And they kind of go, what? What do you mean by, do I know what I don't know? I have a firewall, I have this, I have that. So looking back at this defense in depth, the thing is that all of these different types of technologies are all trained to say, I know what's good, and I know what's bad. And I block or allow based on that. What's been happening, though, is they've been faced with unknown things. They've been faced with the 0 day. They've been faced with the new variant, or the latest crazy thing that's going on, or they walk in and there's been a big headline about a major cyber attack globally, and their manager or their CISO says, "How are we protected? Does this affect us? Are we impacted?" And because they don't know what they don't know, they can't answer those questions. So what happens with defense in depth when you face an unknown threat? It turns out that with an unknown, well, your firewall says, it's encrypted. Maybe I don't know that. Maybe I have something that does that for me deeper in the stack. And it passes to the next layer. 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 And it ultimately passes to the next layer. And every step of the way, you have actually been allowing the threat through. You've actually been allowing it through until it hits the endpoint and craziness happens. And my whole point about with data breach is that the endpoint shouldn't be the last line of defense. It shouldn't be the first line of defense. It shouldn't be in isolation. It shouldn't be, if it can't be found at the endpoint, you're hosed, because that's what ransomware was all about. If you think that you've suffered from ransomware in the last 12 months, you've just had the penetration test that you didn't ask for. And, you should be looking back at your technology and your processes and your people to actually try and improve that. So one of the things that Cisco's been doing is predominantly around the unknown. Because with the unknown, it becomes a known unknown as opposed to an unknown unknown. So uniquely, our technologies have a third disposition state: allow, deny, unknown. And by now knowing that something is unknown, I can now track it. If I get intelligence, I can change my decision. I can actually monitor as it moves through the architecture while it's still unknown. And that's really important, because when it comes to having security, you can't be asked simply, am I secure? Because that's a point in time. In the time it takes you to look at a dashboard or to type in a query, or even to say, yes, we're secure, you may have actually been breached already. So security has to be about being able to block the threats that you know, detect what you've missed, and respond to them. And if you don't have these three capabilities, then really you're not geared up to handle a breach. The shocking thing is just this time gap here between blocking what is known bad or now letting through the unknown that you didn't know was unknown until detecting it when it turns bad. Industry average is 100 days. And that's a real big problem. So, almost done with not the PowerPoint, with my iPad, I should say. So, what am I going to show you today? So, what I'm going to quickly show you is a technology that we have on the endpoint. It's a combination of endpoint protection, but also endpoint detection and response. It's called AMP for Endpoints. It talks to a console, which I'm going to call AMP Cloud, and we're going to log into that. And along the way, it talks out to the internet, and imagine that you have your web proxy between it and the internet. Now, the web proxy will be monitoring outbound connections. It will be even looking at encrypted HTTPS connections. And so what we can do is that instead of thinking that the endpoint has to simply fail by itself and be the only last line of defense, what if we can actually merge the capability of monitoring the traffic coming off of the endpoint from the web proxy and correlate that to the activities which are actually happening on the endpoint? So we married those up into something called cognitive threat analytics. And cognitive is a big data cloud which is actually digesting web proxy information and actually doing advanced machine learning, group association, trust modeling to actually find incredibly weird little patterns in the URLs and seemingly unrelated and stitching them together to actually say this was a threat. I've got a customer that was actually using this, and they had a really warm, squishy feeling when CTA said, you've actually had some data exfiltration. It happened over 91 days, on 6 distinct days in that 91-day period with 38 connections outbound. Now, no SIEM is going to have the data capacity and the analytics to actually build out a web proxy trust model for web logs over 91 days. That's the advantage of a machine learning big data cloud, because it's not your compute, it's not your storage, it's all ours, but we're doing some incredibly advanced analytics around it. And we can then marry that up to the AMP console, and so essentially we're now saying that the endpoint will not fail alone. So I'm going to now pivot into my dashboards. So I'll just refresh this just to make sure that I'm logged in. And what you're seeing here is a dashboard of AMP for Endpoints, as I said. It's showing me hotspots around which endpoints are under attack, which ones are compromised, which ones are doing good stuff, bad stuff, which ones are running vulnerable software. But what I want to also show you is this little guy here. This is cognitive, this is CTA, this is then the marrying of the endpoint telemetry with the web proxy telemetry as well. And so for data breach, what I'm really concerned about is I want to go into cognitive events. These are then the things coming off of the web gateway, in other words, threat-related traffic going through the gateway that obviously is happening because otherwise we would have stopped it, right? So what I'm going to show you is this particular attack here. This is called Sality. It's a piece of malware that actually does some malware distribution, and there's a bit of command and control, and there's a bit of anomalous HTTP as well, where it does some key login activity, and PII bleeds off and leaves your environment. We call that out. We actually say what these are, and we give you the severity of them as well. We've given it a risk factor. We've pulled together the IP addresses that it's been seen. And we've also been showing you these are the seemingly completely unrelated URLs which Cognitive has stitched together and has said, well, this is crazy. What are these things? So I can do a couple of things here. First thing I can do is I'm going to see what's actually happened on the endpoint itself. So I've now moved into something called a trajectory view. This is a view that AMP4Endpoints has that is all about trying to say what's actually happened on the host in terms of processes over time. This is a timeline. If you do any type of incident response, you normally are going to create timelines to be able to see what's been happening. Vertically are the processes running on the machine, what they are talking to, what activities they're making, what connections they're making, and its time across in the horizontal plane. And this yellow banding is not me doing this for emphasis, but this was actually the cognitive event to say, from the web proxy in this time frame, the web proxy has been saying something weird has been happening. So I can now get a view of which processes have been making those weird connections. And as you can see here, red normally means bad, and you're seeing the outbound connections of the weird stuff going on. So that's it from an intimate point of view of the endpoint. What I'm now going to do is I'm going to see the same event, but this time from a traffic-centric point of view from inside Cognitive. Now, where I'm going now is I'm going into the Cognitive event. We're going to see the same URLs that we saw in the endpoint console. And what you're going to see it now is from a traffic point of view. So just wait for this to log in. And of course, being live demos, we've always got to pray to the demo gods. And with any luck, our Wi-Fi network here in the booth has been a little bit hit and miss with so many people around, but here we go. Here are the URLs. So these are the same URLs that I saw here. But instead, I'm now going to be able to stitch together the attack in a different way. I'm now seeing it as a timeline of the connections. I'm seeing the attack actually happen over time. I can see that it started with the downloading of a graphic image, which turned into popping the machine and creating tunneled HTTPS connections outbound. Sality talked out to all sorts of different crazy places. I'm now having to roll up my sleeves and actually start trying to respond. I'm having to now try to say to myself, where did this happen? How did this happen? How do I stop it? What was the methodology here? So one of the things that's really interesting, I'll take this last hop, you can see that it actually fired off to this IP address in Argentina. And wherever you see this little AMP point here, it allows me to pivot back into the AMP console into what was the trajectory view. So this is the general trajectory view of this attack. But I now want to be laser focused as to what's happening. And so now I'm coming in and I'm coming back in and saying which machine is talking to that IP address and which processes are talking to that IP address. And now I can jump in further and go into that trajectory view, but now focus simply on the connections outbound to that last hop of the data exfiltration. And it turned out that these two malicious processes have been making those connections. Now, it's important to note that these are malicious processes. This is a demoing system, so the endpoint is in a posture of auditing. In other words, let it happen so that we can give you visibility for the purpose of a demo. If this is red and this is a malicious disposition, and you can see it here, malicious disposition, the fact is that AMP4Endpoints in its default state is that if it's malicious, I'm going to take out this file, and this wouldn't have happened. So it's important to note that this is simply for visibility for this demo, but we are saying that if it's no malicious, we don't let malicious stuff work. So I've now seen that two malicious processes have been making those outbound connections. And so what I will do is I want to now understand how did this get in the first place. So I can actually filter this trajectory view instead of actually being on the IP address on the file ID, which is called a file shard. Notice that the trajectory is now recalibrated and I've got my timeline of those connections again, but instantly I've actually found out how it came in the first place. And this is actually a VirtualBox tray icon, which obviously is vulnerable and has been popped somehow and has actually dropped the first file, infection 1, and infection 1 then ended up dropping the second malicious file, ANWVXW, very attractive name, and away it goes, and the attack has happened. So I've now got a really specific methodology and view of how the breach happened, and this particular VirtualBox tray icon, well, for the purpose of trying to understand the breach and trying to stop the breach, I could actually put that into an application block and actually stop it from happening in the first place. Now I'm protecting the rest of my devices because I'm now stopping that attack vector. So that's one way of dealing with a breach after it's occurred. The other thing that happens is that, remember I was talking about how data breaches are now very high profile, and what they've been doing is that they've been saying that our IT and security managers have really been fearful of when you get the big new headline in the press overnight and you walk in the next day and your CISO or your risk manager is saying, what is this? How did this happen? Are we affected? Tell me more about it. What's the situation? And so data breaches are, again, about a lack of visibility, and without visibility, you actually have no situational awareness. And so situational awareness comes from having to have context of what's happening in your environment versus intelligence around what's been happening externally. That news feed, that intelligence from a researcher, for example. So I'm going to show you that scenario next in the time allowed. And what I'm going to do is show you, this is the intelligence that Cisco's research team created around WannaCry, which was one of the significant attacks of last year. And we talk about its methodology and what it did, but what we also do in the interests of the public good is we actually publish a lot of the indicators of what it does. And I'm literally just copied it. I've gone over, doesn't matter, I've just copied just plain text. And I'm now going to drop this into another facility within AMP, and it's called visibility. And visibility is about querying our technologies at the back end with their APIs and querying that and marrying it up to intelligence that you can feed externally. So I've just pasted in all of that text, and I've now clicking on investigate. And what it's now doing is now going out and it's now starting to check the situational awareness of what's actually happening on my machines and correlating it back to the intelligence which I just was provided from that blog post. So very quickly, we've already found 38 observables. That consisted of 5 domains, 28 file hashes, and 5 IPs. Now, what we will be able to establish is that as it's rendering out and doing the enrichment, there's at least one target in my environment. It's in here. I've been a victim of WannaCry. So already, in the time it's taken for me to say this, we know that I've been impacted. It's affecting me. What's the extent of it, though? So what I've now got is a map of the global intelligence around WannaCry correlated to my intelligence, or my context, I should say. Here is my target machine. It was actually a WannaCry machine. It's one of our demos. I've just clicked it and it's now focused in on it. So I can see it here. This is my outbreak of WannaCry. You can see how it's been talking to all these different files. This file in particular is extraordinarily chatty. It's been talking to a bunch of IP addresses. Not the relation of what's been happening, but you'll also see that we've mapped additional intelligence and correlated of files and connections all around the intelligence I've provided. This gives me a point of being able to say what is actually working, where is it in my environment, and how do I stop it? Because I can now start driving a response. So with that, I'll roll up, and thanks very much for your time. I hope this has been of interest.